Hello, hi everyone. This is Tushar from Biotechnica. I welcome you all back to the session of General Aptitude. So, in this session, in the previous session, we have completed data interpretation, which CSIR has taken, and today I'll be explaining you probability and arrangements. So join the class as soon as fast so that you can know, you can enhance your knowledge in probability and arrangements. Good evening, Sivali. Am I audible to everyone? Good evening, Vivek. Good evening, Prachi. So this probability and arrangement are very basic and fundamental concept in general aptitude because these are the building blocks. The main motive or the main concept that we need to learn here is counting. So the basic foundation of probability and arrangement is counting. So good evening, Harshit. So once you are doing this will help you to enhance your knowledge. It will help you to increase your aptitude level so that you are better in solving part C questions, part B questions in CSIR. Good evening, Isha. I'm sure you guys are doing great today. Good evening, Sanchari. The slides are clear and visible to everyone? Can you just confirm it? The slides are clear and visible to everyone? Can you just confirm it? Great, Sanchari, great. Thank you. Okay. Good evening, Raj. So we'll just wait for a moment and then we can just dive in. Today, I'm having some fantastic, awesome concepts from probability and arrangement. So we'll be talking about the basic things, how to count, and then we'll build on the things on it. Okay? So share the link as more as you can so that other can also avail this thing. Good evening, Paramita. Okay then, so let's start the session. So before we dive into more integrities of probability and arrangement, I would like to tell you some basic counting principle, some basic counting tips. Now, what is this all about? This revolves all around multiplication and division. This revolves mostly around multiplication and addition. Now we need to know where we need to use this multiplication. We need to know where we want to use this addition. So let's understand this basic thing, that this important basic fundamental mathematical forms, this addition and multiplication, where to use this. Now, this addition, you need to use addition where you have a sense or notion of or, where we have a notion of or in a question. And you need to multiply two factors or constituent where you have a sense of and or a notion of and in a question. So I'll give you an example and this will make this point crystal clear. So let's take an example where we have few cars and bikes. I'm sure you all guys will be having some favorite bikes and car in your mind. So let's consider we are having three bikes and two cars. Okay. Does any one of you want to say the name of the favorite car or bike here? We can use that as an example. Quickly. We can use that as an example. So if we take this example where we are having three bikes and two cars. So if I asked you, so Prachi is saying Tesla. Great. So let's say we are having three bikes and two cars. Now the question arises, if I ask you in how many ways, you can pick one item. If I ask you in how many ways you can pick one item. So basically you are having three bikes and two cars. And the question I'm posing here is, in how many ways you can pick one of these items? So can anyone say in how many ways can we pick one item? In how many ways? We have 3 bikes and 2 cars. In how many ways can we pick one of the item from this? Great, Shivali. Shivali is saying 1 by 5. Sanchari is saying 5. Great, everyone. Great response. You need to actively involve so that you learn things. Okay. So since we are having 3 bikes and 2 cars, so just for the reference, let us call this bike 1, bike 2, and bike 3. And we are having 2 cars. Let's call it car 1 and car 2. Now, either since you have to choose one of the element, you can have either bike 1, or you can have bike 2, or you can have bike 3, or you can have car 1 or car 2. Now note what I'm using regularly. I'm using or. So this or. So eventually how many ways we are having? We are having here 5 ways. And how they are connected? They are connected through or. That is the reason why we are adding it. Is it clear? So we are adding it because we are having a notion of or. Can we have one? We can have one bike or one car and so on so forth. So this is how or is related to addition. I'm sure this point is clear for everyone. Now let's take the similar example and understand for and. Now you are not satisfied with just one item. So I'll be giving you one opportunity where I'm saying that you can choose 2 items. So you are having 3 bikes and 2 cars. The same scenario, you are having 3 bikes and 2 cars, and now you are not satisfied with just one item, so you want to pick up 2. So I'm asking you, in how many ways can you pick one bike and one car? So the question I'm posing is, in how many ways you can have one bike or one car? In how many ways you can have one bike and one car? Quickly, anyone? In how many different ways can we have one bike and one car? Okay, Anupam is saying 2 by 5. Shubhra is saying 1 by 3. Yes, you should try analyzing this. You should make an approach to it. That's the first step towards solving a question. Great. Raj is saying 1 by 3. So let's understand this. What we are having? So we are having 3 bikes and 2 cars. The same scenario that we are having 3 bikes, 2 cars. Now, if you have this choice of selecting one car and a one bike, let's say you are selecting bike 1. So you are having 2 choices. You can either select car 1 or car 2. Is it clear? Since we are choosing bike 1, we have having 2 choices, car 1 or car 2. Similarly, if we are having bike 2, we will be having same 2 choices, car 1 or car 2. Similarly, for bike 3, we will be having car 1 or car 2. So basically, what we are having? We are having 6 ways. So basically, what we are having? We are having 6 ways. Now, how it is coming? 3 ways of taking the 3 bikes that we have and 2 ways of taking the 2 cars that we have. So basically, we are getting 6 ways. I'll write this up so it is visible to everyone. So we are basically having 6 ways. It is because 3 ways from 3 bikes into 2 ways from 2 bikes. So basically, we'll be getting 6. So do you understand now what is this and? So because of this and, we are multiplying. Because of this and, we are multiplying. So in 6 different ways, we can select. Okay? I'm sure this or and concept is clear for everyone. Now let's move to arrangements. So as the name suggests, we have to arrange things. Now for arranging things, the most important quality that we need to have is counting. So what we'll be doing here? We're focusing on how to count. Do you get this? We're focusing on how to count things. So in arrangements, basically you get 3 different types of question. First is forming numbers. Next can be arranging people. So you will be having different kinds of people or sitting arrangement. You have to arrange them. And next you can have arranging letters. So we'll go one by one. We'll go one by one and discuss. So forming numbers. If we are forming numbers, sir. So Pallavi is asking, sir, what if they ask we can pick 2 bikes and 2 cars? No. So if you are having two bikes and two cars, you can just write it down and check it. You are having two bikes. This bike one, let's say you are having bike one and you will having, so if you are having going for bike one, you will be having car one and car two. If you are having bike two, then again car one and car two. So basically we will be having four ways. Basically, you will be having four ways. Okay, is this clear? So Pallavi, is this clear for you? So basically we will be having four ways for that. Okay. So the first kind of arrangement that we are picking is forming numbers. So let's try to understand through few of the questions, how do we deal this? So the first question that I'm posing in front of you is, how many three-digit number can be formed from 1, 2, 3, 4, 5? 1, 2, 3, 4, 5. See, I don't want to just give you the formulas for permutation, combination, or probability. I want you to know this intuitively. It should come to you through the counting. So let's do this through the basis of logic, and then we'll go to the formula. Okay. So how many ways three-digit numbers can be formed from 1, 2, 3, 4, 5 if repetition is allowed? If repetition is allowed. Yes. Everyone try this. How many three-digit number can be formed from 1, 2, 3, 4, 5 if repetition is allowed? So if repetition is what we are having, the question is saying three-digit number. So let's make 3 blocks for three-digit numbers. Is it clear? So we are having 5 numbers from 1, 2, 3, 4, 5. Now when we are saying repetition is not allowed, it means that all the numbers are very distinct. Okay, this means that we cannot have a configuration of 2, 2, 2. We cannot have a configuration of 1, 1, 2. This is clear. So when we are saying repetition is not allowed, it means all the numbers and digits are very distinct. Okay. So if repetition is not allowed and we are having total 5 numbers, and for this we need to make three-digit number. So we can fill up this first block. We can fill up this first digit by 5 ways, because we are having 5 numbers here. We can fill up with 5 ways. Now, what will be the number of ways for the second one? What will be the number of ways for the second one? So since we cannot repeat the number, we are having now 1 less. So we'll be having 4 ways. This is clear? Since we cannot repeat the number, they need to be distinct. So we'll be having 4 ways. Okay. And for the last digit, since already 2 numbers are already used, so we are having just 3 more ways to do it. Okay. Just 3 more ways to do it. Is this clear? Just 3 more ways to do it. So what we are having? So we are having 5 ways into 4 ways into 3 ways. Why we are using into? Because it is and. So it is 5 4s are 20 into 3, 60 ways. So if repetition is not allowed, great Murthy. Yes. So if repetition is not allowed, we'll be getting 60. Now, what if repetition is allowed? That's the next question. What if repetition is allowed? This is the most easiest part. Okay. Now, if we are having 3 blocks, same concept, 3 blocks, but here the numbers can be same. For example, here we can have a scenario of 1 1 1. We can have a scenario of 2 2 1. So we are having this similar digits together here. So in that case, when we are having no restriction upon the type of the digit, so we will be having here 5 ways to fill up, because we are having 5 number. Is this clear? Because we'll be having, great Shubhra is saying 125. Great. So for the second digit also, we'll be having the 10 digit also, will be having the 5 ways, because here we don't have any restriction. This similar 5 numbers can be again used. That's the point. So for the unit place also, we can use 5 ways. So what we are getting? 5 into 5 into 5, 125. So when repetition is not allowed, we'll be getting 125. Is this clear for everyone? So Sivali is saying to explain. Okay, Sivali. So whenever we are having this scenario, where repetition is not allowed. So when repetition is not allowed, what we'll be having? These numbers are not restricted. This first place can have all the 5 different kinds of number. Since there is no condition, repetition, so we can have 5 different ways. So we can have 5 different. Okay, so it is saying repetition not allowed. So if repetition is not allowed, okay, So it just got reversed. So if repetition is not allowed, so when repetition is allowed, if repetition is allowed, there is no restriction basically. So if repetition is allowed, there is no restriction. So in 5 places we can be having 5 ways into 5 ways into 5 ways. So it will be 125. If repetition is not allowed, if repetition is not allowed, so there is some condition, the one we discussed earlier. So when repetition is not allowed, yes, Pallavi, you are rightly pointed out. I just reversed it. So when repetition is not allowed, when repetition is not allowed, we will be having some restriction. So here we can fill in with 5 ways. Since one number is reduced, we cannot fill this. So we'll be filling it with 4 ways. And here we'll be filling with it 3 ways. So basically we'll be getting here 60. This is we'll be getting 125. I'm sure this clears everything. So the important thing is, I'll just repeat it again so that it clarifies all the doubts. When repetition will be allowed, there is no restriction. We can have scenario where we'll be having this number also. Repetition is allowed. We can have any number. There is no restriction. When repetition is not allowed, we need to have distinct number. It need to be 231 or distinct numbers. Okay. So this clears the thing. Okay. Now the question is, next question is, in how many 3-digit odd numbers can be formed? How many 3-digit odd numbers can be formed from 1, 2, 3, 4, 5? First one is repetition allowed and the second one is repetition not allowed. So first let's pick up the easiest thing. So we will be forming 3-digit number. Okay, we'll be forming 3-digit number. So what are the odd numbers present in the sequence? 1, 2, 3, 4, 5. What are the odd numbers? The odd numbers are 1, 3 and 5. This clear? The odd number are 1, 3 and 5. So we can have 3 cases where the unit place. Now what is the odd number? When this unit place is having these numbers which are not divisible by 2, so it will be odd number. So we can have a scenario where the unit place is 1. We can have a scenario where the unit place is 3. We can have a scenario where the unit place is 5. Okay, so we can have these scenarios. Now what will happen? Now in these two places, what we can have? So Shivali is saying, sir, one more will be left. So this is regarding if this if we are regarding this question. Okay, so if we focus on this question, if we are having this 1, 2, 3, 4, 5, so the odd numbers will be 1, 3 and 5. So this unit place will be captured by them. Okay, now what we have, since repetition is allowed and this will be consumed, so we are basically having 5 numbers. So this place can have 5 different ways. This place also can have 5 different ways, because repetition is allowed. We can haul all the numbers again. Similarly for here also we can have 5 different ways. Here also we can have 5 different ways. Similarly for here, 5 different ways. And these are all OR, because we are having 3 different kinds of combination. So we are having OR. Okay, so this is 5 into 5, 25. So basically we'll be having 25 into 3, that is 75. So when repetition is allowed, so we'll be having 75 odd numbers. Okay, so 75 odd numbers. Now let's see when repetition is not allowed. The similar thing we can do. We can have this 3 setup. We can select one number here, 3 here, 5 here, because these are the 3 odd numbers that we are having. Now what we have done, we have restricted one number to it. So how many more numbers are available to fill up in the first place? So 4 more ways we can fill it up. Similarly, since now 2 more numbers are gone, so we'll be having 3 more ways to fill it now. Similarly for here, 4 ways we can fill it up. For here, 3 more ways. Here, 4 more ways. Here, 3 more ways. And how these all are linked? These are linked through OR. These are alternative forms. So we will be adding this thing. So 4 3s are 12, 12, 12. So this will be 36. Got it, Shivali? So this will be 36. Is this clear? So for repetition not allowed, it will be 36. Okay. Now moving to next set of questions, arranging people. Now the question is, how many ways can 6 seats be allotted to 6 people? Now, how many ways? So, Sivali, the last question you are saying, I'll just repeat it again for you. Okay. So, if we are having 3-digit number, if we want to form a 3-digit number, okay, I'll be doing. Okay, I'll be doing again. So, if we are having this 3-digit number, and the first condition is repetition allowed. If the repetition is allowed, so what are the odd numbers that we have? In this 1, 2, 3, 4, 5, what are the odd numbers that we have? We have 1, 3, and 5. These are the odd numbers that we have. Is it clear? Now, since there are 3 odd numbers, so we can have these 3 different combination where the unit place can be filled with 1. This is a combination, or it can be filled by 3, or it can be filled by 5. These are the only 3 possible where it will be odd and it is 3-digit number. So these are the 3 possible combination that we can have. Now we need to fill this 100th place and the 10th place. So since repetition is allowed, we can have this. What did I say? If repetition is allowed, we can have a number like this, 222. So there is no restriction. We can have this number recurring again in the digit. Is that point clear? We can have this point. So we will be having here 5 more ways. We will be having, since 5 numbers are there, we can have this 5 more ways here, 5 more ways here. So basically we can form this number with 25 different ways. Since these are connected with OR, we'll be adding them. So 25 into 3, so it will be 75. Is this clear? Okay, is this clear, Sivali? So when repetition is allowed, we'll be having 75. If repetition is not allowed, I'll just show one case. You're doing the same thing. Same 3 cases we'll be doing. Same 3 cases we'll be doing. But the thing is, now we have restricted. The one number we have already lost. So in the 100th place, we will be having 4 different ways. Okay. And in the 10th place will be, since 2 more numbers are consumed now, so we'll be having 3 more ways. So effectively for a particular combination, we'll be having 12. Okay, 12. So 12 plus 12 plus 12, that is, we'll be getting 36. Okay, this clears it. So for when repetition is allowed, that is the 75. When repetition not allowed, it's 36. Okay. Now moving to the next type of question, that is arranging people. Great, Anupam. That is arranging people. So how many ways 6 seats can be allotted to 6 people? This is the question that I'm posing. Everyone, you can try this question out. How many ways 6 seats can be allotted? So what is this thing having? We are having 6 people and we need to fill up 6 seats. 1, 2, 3, 4, 5, 6. So we are having 6 seats. So how can we fill up? So there are 6 seats. So the first seat can be filled up in 6 ways because there are 6 different people. So it can be filled in 6 different ways. And the second seat, since one people is already sat. So how many more people are there? There are 5 more people. So this seat can be filled by 5 different ways by 5 different peoples. Similarly, here 4 different ways, here 3 different ways, here 2 different ways, here since only one guy is left, so it has no choice, so it will be filled there. So what we are having basically 6 into 5 into 4 into 3 into 2 into 1. Okay, great, Romy. So this is basically 6 factorial. So this is basically 6 factorial. So if we are having 6 seats and we need to fill up with the help of 6 people, so each seat, the first seat will be having 6 different kinds of possibilities, and slowly, gradually, it will be getting reduced. So if we are having 6 seats and 6 people, it will be 6 factorial. Now this is a new thing where 6 factorial is given from the product of 1 to 6, 1 to 6. Similarly, if we are saying 2 factorial, it will be 1 into 2. Is this clear? This is the extra information. So when we are talking about 2 factorial, it will be 1 into 2. If we are taking n factorial, it will be 1 into 2 till n factorial, till n into n minus 1 into n. This will be termed 1 into 2 dot 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 till n minus 1 into n. The last term will be there. Great. So we'll be having 6 factorial. Now the next question is, how many ways 6 people can sit in a circular arrangement? Now that we saw in a linear arrangement. Now the question is, how many ways 6 people can sit in a circular arrangement? How many ways 6 people can sit in a circular arrangement? So these six people. So Meghna is saying in previous question, if repetition is allowed, then how 4 and 3 changes in the 10th position? Meghna, you are talking about which question? Can you please write the question number? So focus on this question. So we are having 6 people and we want to arrange them in the circular arrangement. So if we are talking about circular arrangement, we'll be having this. We'll be having 6 seats. In a circular arrangement, we are having 6 seats. Now we have the task for assigning seats to each of them. Okay. Now, the important thing to note here, when the first person comes and sits, focus and understand. When the first person comes and sits, now for him, all the seats are same. For him, all the seats are same. No matter he takes this position or this position, so it will be same equivalent thing. So he has only one way to do it because there is no alternatives. All the positions are same. So he has only one way to do it. Okay. Whether he sits in the post position 1, 2, 3 doesn't make sense, doesn't make anything different because it is all same from different. Now, but when the second person comes, let's say the first person comes and sits over here. Okay. Meghna is saying forming numbers 3-digit odd numbers. So Meghna, in 3-digit odd numbers, so this unit place can have 1, 3, and 5. This unit place can have 1, 3, and 5. Now what these are OR, so we need to add them. So when repetition is allowed, since there are 5 numbers, since there are 5 different numbers and there is no restriction, we can again use this one. Important thing you should understand that since 1 is in the unit place, this can also be used in the 100 place. So we can fill this in 5 different ways. Similarly, here also 5 different ways. That is why we were having 25 and this 3 will be having the same, so we'll be having 75. But when we are talking about not repetition not allowed, when we are talking about not repetition allowed, in that particular case, this 5 and won't be there since we have already associated 1. What we are left? We are reducing one number. So we are left with just the 4 numbers. Okay. So we will be having 4 ways and here 3 ways. So it will be 12. And henceforth, we can see it will be coming to 36. Okay. I hope this clears your doubt right now. So let's focus on this question, okay, where we are seeing circular arrangement. So I was saying that when the first person comes, he has no limitation. He can sit wherever, and wherever he sits, it does not make a change because whether he sits on the point 1 or point 2, that does not affect the orientation. But when the next member comes in, the second member comes in, this changes the scenario because now once the first one is sitting in this position, the second one for this position, all have become now distinct because let's consider if this second guy is sitting over here. So for this second guy, the guy on the first position is sitting towards the right. But if this guy will be sitting on the left, so what will happen? This guy will be sitting, first guy will be sitting towards left. So these are basically all the distinct position. So what has happened? Once the first person has come and sat on the table, it has changed the mechanism. So now all the positions are become distinct. They are not same. So what will happen? So the second guy, since how many posts we are having? Already 6 were there, 1 is occupied. So the second person can fill this in 5 different ways because he can come and sit in second position, or he can come and sit in third position. But this second and third are very different. See, here only one gap, here there is no gap, here there is one gap. So all these are distinct. Okay, all these are distinct. So the second position can be filled in 5 ways. Similarly, the third guy will have 4 ways to fill it. Similarly, the fourth guy will have 3 ways to fill it. The fifth guy will have 2 ways to fill it, and the sixth guy will have 1 ways to fill it. So what we have done, we have got here 5. I'm writing this above so that so if all these cases are and so we need to multiply. First position is coming here and the second will come and the third will come, so we'll be multiplying. So you see how this or and is getting used. So we will be multiplying here. So this is 5 into 4 into 3 into 2 into 1. So what we have got? We have got here 5 factorial. This is what we have got. Great, Pallavi. So Pallavi is saying 5 factorial. Great. So we'll be getting 5 factorial. Is this clear? 5 factorial. So whenever we are having 6 people and we have a circular arrangement, so the number of possible arrangements will be n minus 1 factorial. So this is a trick so that you can solve easily. So I wanted you to know the mechanism behind it, or how we can solve it. Even if you don't know the formula, you should be able to do it intuitively. That's what. So the 6 people can sit in n minus 1. So this will be 5 factorial. Is this clear for everyone? Now moving to the different kind of question that we give generally is arranging letters. Look at how we arrange this letter. So the first question that we are having is, how many different ways can the letter of the word men be arranged? Let's start with a simple one. Let's start with the men word. So in how many different ways this men can be arranged? Try solving along with me so that you develop this approach. It's excellent that you are participating and solving this question, because you have already succeeded in putting a step forward to solving this question. That's a great thing. So men. So when we have this word men, so this men has three letters. Men has 3 letters. So 3 letters are there. Now if you want to arrange them, the one thing you can do, you can think them as 3 brackets or 3 blocks are there, and where you will be using each letter to fill that up. Is that clear? So we are having 3 letters. So we want to this. So we are having 3 letters. We want to arrange them. So how many ways we can do it? Just similar to the sitting arrangement that we are doing, we need to do this also. So there are 3 letters. The first one can be filled in 3 ways. One letter is less. The second can be filled in 2 ways. The third can be filled in only 1 way. Okay. So basically, since and is coming in between, so we'll be multiplying it. So we'll be getting basically 6. So this men, M-E-N, this 3-lettered word can be rewritten in 6 different ways. So basically we are getting 6. Clear everyone? Great Meghna, great Romy. Now let's level up this with this question. How many different ways can the letter of the word excessive can be arranged? Try solving this question. If you have understood the previous one, you can use the same concept to solve it. Okay. In how many different ways the letter of the word excessive can be arranged? So let me just write the word for you, excessive. So the first thing that you want to do here in solving this question is count the number of letters that you have. So how many letters we are having? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are having 9 letters. Here we are having 9 letters. So in the last thing, what we saw that if there were 3 places and we wanted to arrange 3, so it was basically 3 factorial. 3 factorial is coming. What we got? 3 into 2 into 1 we got. That was coming to 6. So that was basically equal to 3 factorial. So if we have 9 letters, so the total number of arrangements would be 9 factorial. Is this 9 factorial? But there is a catch. What is the catch? Now we are having similar number or similar letters, double or triple. So that is important thing to note here. So had this been a simple letter where there is no repetition, we would have got 9 factorial. But since you can see here, E is written 3 times and S is written 2 times. You can note here, E is written 1, 2, 3. E is written 3 times and S is written 2 times. Now this thing changes the equation. I'll explain you why. So let's consider a simple example. Let's take an example of word I. E-Y-E. Now there are 3 letters. Considering there are 3 letters, we will be able to write 3 factorial ways or 6 ways. We can write this letter similar to men. But here we will be having E. 2 E's are there. So when we are arranging dates, we might get a scenario where we will be having, just for a moment, consider this 2 E's to be different, E1 and E2. Now we might have a scenario where when we are completely counting this, we'll be having this thing. When we are considering all the 6 possibilities for the word EYEI, we will be considering this also. But in actuality, in reality, these 2 E's are same. So what we have done, we have counted it twice. That's the thing, we have counted it twice. So how do we rectify that? We need to divide it with that. Okay, so this will be 3 factorial divided by 2 factorial. The similar concept we need to use here. So If this would have been all distinct letters, so we would have got 9 factorial. But since we are having 3 E's and 2 S together, so we are counting it more. We have doubled and tripled it. So we need to reduce that in that factor. So we'll be dividing that with 3 factorial and 2 factorial. Is this clear for everyone? Is this clear for everyone? So we'll dividing it with 3 factorial and 2 factorial. Great. So top, it's not visible. I'll write it again here. So you have seen this I concept, where if we are having a three-lettered word I, so had this been a distinct letters, we would have got all the 3. So we would be getting 3 factorial, or the 6th way we would have written it. But since E is coming twice, so when we are writing all the possibilities, we might have come across a point where we would have got EEY. Now for a moment, consider this E and this E to be distinct, different. So the next combination that we would have got when we are calculating all these 6, we would have got this. But in English alphabet, all these E's are same basically. So that is the reason we need to divide. Okay, that is why we are getting 9 factorial by 3 factorial by 2 factorial. Option B. I'm sure this clears the thing. Okay, now moving to the great Romy. Moving to the next question. In how many different ways can the letter of the word football be arranged such that all the vowels are always together? In how many different ways is it played? So what are the vowels present in this word? Consider, see this word football. What are the vowels present in the word? So in English alphabet, we have 5 vowels. A, E, I, O, U. So what are the vowels present? You can note easily. So we have 2 O's and A and a single A, 2 O and a single A. So if we write this football, so let's separate the vowels. So what are the vowels that we are having? O, O and A. And what are the consonants that we are having? F, T, B, L, L. These are the consonants we are having. We are having F, T, B, L, L. So the next thing that we want to do when you are calculating such a concept, try to put a packet around this OOA. So basically consider this 3 letters to be 1 letter, so that you consider this 1 letter and arrange them. So we were having F, T, B, L, L, and this OOA, you consider this to be as a single letter. So how many different digits will be having? 1, 2, 3, 4, 5, 6. So we are having 6 different things. So we are having 6 different things here. But the important point to catch here is we are having 2 L's are here. So it will be 6 factorial by 2 factorial. This is clear. We are having F, T, B, L, L, and consider this OOA to be 1 unit. So we are having 6 digits or 6 letters here. So we will be getting 6 factorial. Now since L is twice, we'll be dividing by 2 factorial. This is clear. But this OOA is not, it's not a single term. This is a constituent of 3 terms. So these 3 terms can be arranged in itself by 3 factorial divided by 2 factorial way. The same concept, the excessive concept that you use. 3 letters are there, so we can arrange it in 3 factorial ways. But since 2 letters are same, so it will be 3 factorial divided by 2 factorial. So for OOA, we can arrange that in 3 factorial divided by 2 factorial way. So this is what we'll be getting. So we'll be getting 6 factorial by 2 factorial into 3 factorial by 2 factorial. If you solve it, you will be getting it to be 1080. Is this clear for everyone? 1080. Okay, so just you need to focus that you need, since it is written that all the vowels are always together. So what you do, you put all the vowels together. OOA, all the vowels together, put it in a bracket or packet and consider it to be 1 term. Calculate this thing. There will be 6 different terms divided by 2 factorial. We'll get the combination. But this OOA are different things. So for that, we'll be having 3 different ways. 3 factorial ways to do it, but since OO is coming double, so you need to divide it by 2 factorial. So the answer will coming 1080. Now coming to the next, what is the number of distinct arrangements of letters of the word UGC CSIR so that you and I can come together? How can do this? The same thing we can do, but what it is written? It is written you and I cannot come together. You and I cannot come together. So for this type of questions, what you can do, you can find the cases where you and I is coming together. So you can find the cases, you can first find all the cases, you can find all the possible cases minus cases where you and I are together. If you do that, you will get the cases where you and I does not come together. So count the number of digits. It is having letters 1, 2, 3, 4, 5, 6, 7. So we are having basically 7 in UGC CSIR. We are having 7 letters. So for that we'll be getting 7 factorial. Is it clear? 7 factorial. But this 2 will be there, but this 2 C's are there. So for that we'll be getting 7 factorial by 2 factorial. So this is the all possible combinations, all possible different things that we can have. 7 factorial by 2 factorial minus the point where you and I are coming together. The same concept you can use. So write what I taught you. You can write GCCSR, okay, and then you can put you and I together. That's what we did. We put you and I together and then count 1, 2, 3, 4, 5, 6. So 6 different digits or letters are present. So 6 factorial, but C is coming twice. That's what C is coming twice. So the number of ways we can arrange it 6 factorial by 2 factorial. So the cases or ways in which you and I are together is 6 factorial by 2 factorial. 6 factorial by 2 factorial. But the important thing you need to know here that this you and I are not a single term. So what will happen? These are 2 different terms. So for each number, you will be coming different. If we are arranging one place to be ui, so iu will be different thing. So there are 2 possibilities for this. So we will multiply with 2. So we will multiply this with 2. Okay, we'll multiply it with this 2. Now if we solve this, we will getting the answer 1800. So focus on the approach how we are taking it. Focus on the approach how we are taking it. Okay, focus on the approach rather than, so I'm teaching you how to approach the question. So focus on the approach. So you got this point. First you need to club you, and so we wanted to find where you and I cannot come together. So we wanted all the possibilities minus where you and I are coming together. Okay, now this till now what we discussed how we are arranging things. So what we did, we counted, but permutation is nothing but that counting. So what we did, we counted. So I wanted to develop your intuitive sense. So permutation is what we counted. So permutation, when we are writing NPR, so Anupam is saying why we are multiplying by 2. Anupam, you can see here when we are writing GCCSRUI, so we are putting this UI in a common bracket. But actually, is this UI a single term? No, it is 2 different letters. But for our convenience, we have put it to 1. So when we are expanding this, whenever, let's consider this, you will be having this. If this is a letter GCCSRUI, so you can have the other letter with just the same initial part and I and U different. So for each letter you are having 2 combination. Is that clear? Each letter you are having 2 combination. So that is why we are multiplying with 2. Okay. So in permutation, we are just counting. We are just arranging things. How? So when we are writing NPR, what we are doing? We are arranging R things. We did that thing. We are arranging R things out of N things. So when we were doing 3 chairs, when we are having 3 things and we filled 3. So what we did? We arranged it basically. But in combination, what we'll do? In combination, we'll be selecting things. In combination, we want to select things. Irrespective of the order, in combination, we will be selecting things. Okay. Now, how we'll be selecting? When we are writing NCR, it means we are selecting R things out of N things. We are selecting R things out of N things. So the formula is given by N factorial upon R factorial into N minus R factorial. Is this clear? So we have seen how we can count number intuitively, and this is the formulas for permutation and combination. I want you to develop this intuitive sense of counting, how we can count. So there is a question for combination that will help you to understand. The question is, how many different salads can be formed from cauliflower, tomato, onion, potatoes, and carrot? This is the question that we are having. In how many different ways this can be selected? So what are the ingredients that we are having? So what are the different ingredients that we are having? We are having cauliflower, tomato, 1, 2, 3, 4, 5. So basically in this salad, we are having 5 different ingredients. We are having 5 different ingredients we are having. So when we want to form this salad, a person can say that, yes, I want only one thing. So either he can use only cauliflower. So one case will be there where either you can use one of the ingredients that you have. Is this clear? We are having 5 ingredients. We can make salad out of it. But we can think that one person will come. No, she will say, no, 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 I just want one ingredient in it. So we can have one ingredient. So from the 5 ingredients, we need to pick up one ingredient. How we can do it? 5C1. We are selecting out of 5 ingredients one ingredient. So it is 5C1. So how it will be? 5 factorial upon 1 factorial into 4 factorial. That's what we have seen. N factorial divided by r factorial into n minus r factorial. So it will be coming to 5. Now someone will come and say, no, I want two things. I'll say, let's say I want to mix potatoes and onions. So we can have two things. We can, in this salad, we can have two things also. C5C2, we can have two things. So this will be 2 factorial into 3 factorial. So we'll be guessing 10. Or we can have similarly 3 things. The same we can do and we'll getting here 10. Or we can add 4 things into the salad for our convenience. If we solve it, we'll getting 5. Or we can add all the things together. 5C5. Okay, 5C5. So when we are doing 5C5, we'll be getting 1. So what we have done, we are having this 5 different ingredients where the possibility is one can pick up only one type of ingredient, or he can add 2 and make the salad. Similarly, we can have all the added together. So if we add all this together, since these are connected with or, so we'll be adding it. So if we add it, we'll be getting 31. If we add it, we'll be getting 31. This is how we solve combination things. Now coming to probability. Now what does this probability means? Probability means the number of chances of getting a particular event. The number of chances, probability is the number that reflect the chances of happening a particular event to occur. Okay. Now mathematically, how can we say that? Since it is the chance of an event to occur, so what we want? We want the two things. We need to see how many events are there. We need to see the total outcome, and we need to see the favorable outcome. So if we want to compute probability, it is number of favorable outcomes upon the total number of outcomes. So using this, we can find the probability. Now, if there is a question, if 3 unbiased coins are there, if 3 unbiased coins are tossed, what is the probability of getting at most 2 heads? If 3 unbiased coins are there. Now, what is the probability of tossing? If we are tossing one coin, what is the probability that we'll get a head or a tail? If we toss a coin, what we have? For a coin, we have a head and a tail. So what is the probability of getting a head or a tail? So it is 1/2. It is 1/2. The probability of getting a head or a tail is 1/2. So if three different coins are tossed, so what all possibilities we can have? Let's see. So if we are tossing 3 coins, so we may have situation where we are getting all 3 heads. We may have a situation where getting 2 heads and a tail. We may have a situation where we getting a single head and a double tail. Or we may so have the situation where we are having 3 tails, or we can have 2 tails and a head, or we can have single tail and a 2 head, or we can have head, tail, or we can have tail, head, tail. So these are the all possible combinations we can have when we are tossing 3 coins. Is that clear? When we are tossing 3 coins, we'll get this kind of 8 combinations. 8 combinations we are getting. 8 different formations we are getting. Okay. Raj is saying 3/8. Okay, let's see. Now the next important thing is the question is at most 2 heads. This is the tricky part. At most 2 head. So whenever we are saying at most, it means at the maximum we can have two heads. So it implies at the maximum we can have two heads, but we can also have one head or we can have zero heads. That's what it is. Maximum two heads. So we can have 0, 1 or 2. Okay. So count the systems where we are having two heads or one head or zero head. So we'll be having 7 such combination. We'll be having 7, except this where we are having 3 heads, we can have all the combination. So we'll be having 7 upon 8. So the probability of getting what? So what did we know? We calculated, we know this formula. So total number of spaces or chances, total number of chances of the event, total number of that this have is 8. Total number of combination, total number of different combination we have is 8. And from this 8, the 7 has most two heads. So this will be 7 by 8. Okay. This clears 7 by 8. Great. This clears 7 by 8. Now moving to the next question. The probability that a ticketless traveler is caught during a trip is 0.1. The probability that a ticketless traveler caught in a trip is 0.1. If the traveler makes 4 trips, the probability that he or she will be caught at least one in this trip is, what is the probability if the ticketless traveler is caught once? So see here, the probability of getting caught. What is the probability of getting caught? The probability of getting caught is 0.1. Now we want to find the case where what is happening? At least one of the trip, the probability that he or she will be caught at least one of the trip. So what does this mean? If we find what we can do if the total probability is 1, so 1 minus the probability of not catching, the probability of not getting caught, 1 minus the probability of not getting caught. If we do that, we'll be getting the probability of at least 1 when it is getting caught. Is this clear? 1 is the total probability. So if 0.9, Paramita is asking 7 by 8. See Paramita, we have 8 different combinations. When we are tossing 3 coins, we'll be having 8 different combinations. Okay, is that clear? 8 different combination. But since it is at most 2 head, we are telling at most. So focus Paramita. When we are having at most 2 heads, what does it mean? At the maximum. So there is no lower boundary to it. So we can have either 0, we can have 1, we can have 2. Is that clear? We can have 0, we can have 2, or we can have 1. So we can have either 1 head or 0 head or 2 heads. So there is only one case where we are having 3 heads. So only that case will exclude and others will be combining, because that's what it is asking. It is asking at most 2 heads. So what we'll be getting? We'll be getting 7. Is that clear? We're getting 7. So the probability, now focus on this question. The probability that a ticketless traveler is caught during a trip is 0.1. So probability of getting caught is 0.1. Now what is it is asking? It is asking the probability that he or she will be caught at least one in the trip. So what it will be? It will be 1 minus the probability of not getting caught in a particular event. So what is the probability of not getting caught? It's 0.9. If getting caught is 0.1, not getting caught is 0.9. He's taking 4 trips. He's making 4 trips. So if he is making 4 trips, so what is the probability in the first trip of not getting caught? It's 0.9. And the second trip, what is the probability of not getting caught in the second trip? It is again 0.9. Similarly, for the third also 0.9, for the fourth also 0.9. So the probability of not getting caught, is basically 0.9 to the power 4. So the probability that he or she will be caught during at least one of the trip is 1 minus 0.9 to the power 4. Is this clear? Since the probability of getting caught is 0.1, so for a particular event, the probability of not getting caught will be 0.9. Since he is making 4 events, so in particular one event there is probability 0.9, in the other he will be 0.9, 0.9, 0.9, so it will be multiplied. Okay, so 1 minus 0.9 to the power 4. Now moving to the next question. The next question is two students are solving the same problem. So Shivali is saying, okay, So I had the same question, but okay. So okay, Romy is saying 9 into 4 for 4 trips for getting caught. So option yes, correct, Romy, you are correct. Yes. So for the 4 will be 0.9 to the power 4. So it will be great, Romy. Yes. So moving to the next question. Two students are solving the same problem independently. Two students are solving the same problem independently. If the probability that the first one solves the problem is 3 by 5, provided that first one solves the problem is 3 by 5, and the probability that the second one solves the problem is 4 by 5, what is the probability that at least one of them solves the problem? What is the probability that at least one of them solves the problem? So there are two students. So the probability of solving for the first student is 3 by 5. Then what is the probability that the first student won't solve the question? Is 2 by 5. Since the total probability for a person to be solving is 1, so if the first person cannot solve, the first person, the probability is 3 by 5, then what is the probability that the first person cannot solve? It's 2 by 5. So that if we add them, it will be 1. Similarly, the probability for solving a question by person 2 is 4 by 5. So what is the probability that the second person cannot solve the question? It is 1 by 5. Okay. Now what does it want? It wants what is the probability that at least one of them solves the problem. It is asking at least one of them solves the problem. Now how this will find how one, so at least one can solve the problem means either both are solving, one or two, or one is solving. So either P1 and P2 both will be solving, plus P1 is solving but P2 can't solve, plus P1 can't solve into P2 is solving. These are the possibilities we have when we are seeing that we want the probability of at least one person to solving. But we know if we know just there is a we know that the probability that both won't be solving is this, and if we add all this it will be 1. The entire probability of this thing is 1. So what it involves, it involves when 1 and 2 both are solving, it involves when 1 is not solving, 2 is solving, plus 1 is solving, 2 is not solving, plus both are not solving. The entire probability will be 1, but we want to find this, so it will be 1 minus probability that 1 cannot solve and probability that 2 cannot solve. So it is 1 minus this. So what it will be? 1 minus 2 by 5 into 1 by 5. It is visible to everyone. So it is 1 minus, so it will be basically 1 minus 2 by 25. It is basically 1 minus 2 by 25. So it is basically 23 by 25. It is basically 23 by 25. I'm sure this is clear for everyone. This is 23 by 25. So just you need to focus that if it is a probability is given for doing a thing, then the negation, the other one will be 1 minus that thing. So if the probability of doing a question by P1 is 3 by 5, the probability that it cannot be done by P1 is 2 by 5. So if the total probability will be 1, so we need to subtract for finding at least one of them. Is this clear for everyone? Now let's consider this question. Students of a school are divided into 4 groups. What is the probability that 3 friends get into the same group? Students of a school are divided into 4 groups. What is the probability that 3 friends get into the same group? So there are 4 groups. 4 groups. A, B, C, D. There are 4 groups A, B, C, D, and we are having 3 friends. So what can happen? What it is asking that same group they will go. So it may so happen that all these friends will come to this group A group, or these friends can come to this group all 3, or this or this. Now the question is, what is the probability that one of this friend is getting into 4 groups, one of the group? Since there are 4 groups, so what is the probability of getting into one group? It is 1 by 4. Since there are 4 groups, so getting into one group, the probability of getting into one group will be 1 by 4. Okay. So for a single friend, it will 1 by 4. For the other guy also, that is the same probability. There are 4 groups for him also. So the probability for getting into a particular group is 1 by 4. So 1 by 4 here into 1 by 4 for the third guy also. Plus for the B group also will be having this 1 by 4 into 1 by 4 into 1 by 4. plus same thing for the C group, because we are considering all three cases. Here also same thing. So basically we'll be having 1 by 4 into 1 by 4 into 1 by 4 into 4. Since this is considered 4 times into 4. Okay, great Romy. But you just need to consider, yes, since there are Romy, you just need to consider one thing. Since there are 4 conditions, since there are 4 different combinations, so we need to add them also. So this 4 will be multiplied. Just correct that. 4 will be multiplied. The probability of going into A group is 1 by 4 into 1 by 4 into 1 by 4. But they want all this combination. So they can, all 3 friends can either go to A or B or C. So we need to add all these things, A plus B plus C plus D. So we're getting 1 by 4 into 1 by 4 into 1 by 4. And for this, since 4 are there, into 4 we can do. So we'll be getting 1 by 16. Please rectify that, 1 by 16. Great Paramita, 1 by 16. Now let's move to this question. It's saying that there are 12 balls. There are 12 balls, each of the color red, green, and blue. There are 12 balls with each color red, green, and blue, and yellow are put in a box and mixed. If 3 balls are picked at a random without replacement, the probability that all the balls are of the same color. So what we have here, what are the important things? What are the important things? We are having here 12 balls. Okay, we are having here 12 balls. If we are having here 12 balls, what in this 12 balls we are having 3 red, 3 green, 3 blue, and 3 yellow. These are the 4 things that we are having. Now we need to pick up if 3 balls are picked. So now consider 12 balls are there. In how many different ways you can pick that up? We need to use combination. How many different ways we can pick 3 balls from these 12 balls? So that will be 12C3. 12C3. Is this clear? Since we are having 12 balls, we want to pick up 3 balls. That will be 12C3. Is this clear? So this is the total number of possibilities that we are having, 12C3. Now what we want? See, now what we want? Now we want all 3 balls. We want, if all 3 balls are picked at random without replacement, all 3 balls are of the same color. So what we can have? We can have either red, green, blue, yellow. So we can have either 3 red or 3 green or 3 blue. This is what. But how many balls we are having for red? 3 balls only we are having. Do you get it? We need to have same color. So all the 3 balls same means all the 3 balls will be same. R3, RG, RB, and Y. But we are having total 3 similar color balls. So from this 3 similar color balls, so what we can have? Either we can have, we need to select, either we can have 3C3, 3C3. We are from 3, we need to select 3 same color balls. But consider for red, for red we are having 3 balls, and we need to consider them all to combine them so that they are together. So C3, 3C3 by 12C3. This is, if we considering this red plus, because we need to consider for other color also. For red, this is C3, 3C3 divided by 12C3. Similarly, for green also it will be same, because 3 balls are there and all are colored, and we need to pick them all so that they are together. So 3C3 by 12C3. Similarly for blue, similarly for yellow, and since these are all different forms, so we need to add them so that we get the total thing. So effectively we will getting C3, 3C3 divided by 12C3. 4 times into 4 we can do. 4 times into 4 we can do. And if you solve this, C 3C3 will be 1. C3C3 will be 1. And this 12C3 will be 220 into 4. So basically you will getting 1 by 55. Basically you will getting 1 by 55. Basically we'll be getting 1 by 55. So the probability is 1 by 55. First you need to consider there are 12 balls. So you need to pick up 3 balls. So how many? 12C3. See, three ways you can pick these balls. Now, what we want? You want all the three colors to be combined. So you are having three different balls, four different balls together, but each ball is three in number, same. So you need to take all those. So that will be 3C3. Okay, this is clear? Great, great. Now come to this question. A point is chosen at random from a circular disk shown in the figure. What is the probability that a point lies in the sector OAB? So what we know? Probability, we know for probability this total number of possibilities, total possibilities by the outcome that we get here. So for a circle, the total area, for a circle, the total area is pi r square. We will be bringing such aptitude session where we're discussing geometry and mensuration. So please log in, and you need to come here and watch this session so that you gain this complete knowledge for geometry. So now I'm just saying the formula, it's pi r square, but in later session we will be discussing it. Okay, so the area of the circle is pi r square. Okay, area of the circle is pi r square, but we are given this sector. So what is the probability that the point lies in the sector? So we need to find the area of the sector. Explain the solution. So great. So we need to find what is the probability that the point lies in this sector. So if we are having this sector OAB, so what is the area of the sector? The area of the sector is given by, if the angle is theta, here it is given x, so it is x upon 2 pi into pi r square. This is the area of the sector. So basically it is the angle given divided by the ratio 2 pi into pi r square. So how will find the probability? So probability is equal to what? X upon 2 pi into pi r square divided by the total area of the square, which is pi r square. So what we'll be getting? We'll getting the probability to be x upon 2 pi. We'll getting the probability to be x upon 2 pi. So the option C is correct. Okay. So this is how we have covered probability and arrangements. So I'm sure that you would have learned a lot in this session. You have gained a lot. You need to focus on counting things. You need to intuitively develop that sense of counting for solving this question. But if you want to learn more things related to aptitude, related to biology, biological sciences and chemical sciences, do join Biotechnica and Rasayanika. We are providing more deeper concept. We will be explaining these things in greater depth so that it will be helpful for your career, for your ambition to create clear CSIR net and gate. So with this, okay, I'll take the last question. Pallavi is asking why x by 2 pi. See Pallavi, what we have, the angle given to is x. Sector, its sector, the angle is given x. So the ratio, see, let's consider the total area of the circle is pi r square. Okay, now that I'll just, so pi r square is the area of the circle. Now when we are considering the area entirely, it is 2 pi for the 360 degree. Do you get this point? For the entire 360 degree, we are having pi r square. But now we want to find the area for this small sector only, which is x. So for, you can use the elementary method. For 1 degree, how much it will be? Pi r square by 360. For x degree, how much it will be? It will be x upon 360 into pi r square. Do you get this? And what is this 360 degree? It is nothing but 2 pi. Do you get this? Great, Pallavi, great. So it was great interacting with you guys. It was an awesome session. So for knowing or learning this concept with greater details, you need to subscribe to Biotechnica, you need to subscribe to Rasayanika. For chemical sciences, we are providing more such content, and we'll be bringing more content for aptitude also in various topics like profit and loss, geometry, mensurations and all. So please subscribe to them. Please do check their links and take these classes. That will be a great benefit for you. It will help you to enhance this knowledge of you that you are having. Apart from that, in Biotechnica, we will be starting Raftar batch. So if you are having any confusion regarding the preparation of CSIR net and gate, you can come there. We are more than happy to help you, to assist you with your dream, so that once you are joining us, we can help you to achieve that. So thank you all for remaining with me. It was a great session with you all, guys. I know it was difficult for me to take all your queries in between, but if there is any doubt, I'll love to take that. Okay. Thank you all.